Welcome very much to today's live session at Digital Africa. Today we'll be talking about Scalable Supervised Machine Learning and how you can use it to monitor your crop conditions. I've put the link to the presentation in the chat so that we will be able to follow up. Thank you so much and welcome. So the Digital Africa program has been set up a few years ago, 4 years ago, to help the continent address various thematic areas from agriculture, water, land, urbanization and coastal management, and all the stakeholders are included in this important process, including the continental services, as well as some of the solutions that we have, like as today's presentation. So you're able to access the Digital Africa platform through the Digital Africa map, as well as the sandbox, which will be able to demonstrate, and as well you can access in your other GIS software, namely QGIS and Esri and other softwares via an API, and then you can access the free online resources that we have on the platform. So for today's example, supervised machine learning in monitoring crop conditions, we'll use an example of Faiyum in Egypt, where we examine a workflow that helps us train a machine learning model. This is based on the data that was collected on some crops where they use irrigation. And using this workflow, you can actually unlock agricultural intelligence, looking at the training data, which is key, looking at the various steps, how we get the training data, classify the data, and preset classification. So we have a series of notebooks that we have in a real world folder with a scalable machine learning folder, where we have a series of notebooks, which are namely 5. And in this workflow, based on open data cube technology, you can actually able to modify the workflow using your own training data for the areas that you've collected. And you can be able to inspect the training data, of course, evaluate with a feed for purpose classifier and classify the data. So the one which is used is object-based filtering. This notebook, of course, we have some extra steps that you can develop, and you'll be able to see the workaround shortly. So in your real world folder, you'll see we have a folder called Scalable Machine Learning. And in this folder, we have a folder for the data sets, and we have the results where they are stored. And you start with the first notebook, you run it, then you go to the second one, then the third one, then the fourth one, then the fifth one. It's a step-by-step process. So it actually starts by examining what is a crop and what is a non-crop based on those values, 1 to 0. And this is for training data, which was shared with one of our stakeholders. So this is very key for any of your data sets that you have. You have some data, field data that you've collected. You can actually even substitute it in this particular folder and you can run it. So in this particular case, you know the format of our data is in the GeoSum file, which is very key for starting to work with your data. Second part now, as you can see, is to extract the training data using our open data cube technology. And this is the step-by-step where you have to locate where your data is actually located in the data folder. And now you'll be able to see a step-by-step process. So the first one is actually now extracting the data. Second one is actually now inspecting the data to make sure that it's fit for purpose. Then thirdly is to evaluate your classifier if it's really workable. Then fourthly is to classify the satellite data itself. And as you can see, the classifier we use is an object-based classifier, and then which is in the GOT file. And then as you get the background for object-based filtering of pixels, we normally use the geographic object-based image analysis, which you know these from other softwares that you've used. I know you have other softwares which do image segmentation, even looking at Clark or DC, other softwares that you've used, even Envy. And from that, when you run the segmentation, you're able to generate some statistics that you're able to actually output for your results. Then the other part is to actually see some of the data sets that we have for these particular notebooks. Just as an example, I wish to pause first so that I can do the actual step-by-step demonstration so that we can actually follow where we are or where we are supposed to be. So as I shown you earlier on, we were at the first one where we have the machine learning. So this is the step where we were, and as you can see, we've narrowed where our data set is, and here just to show you step by step what that actually entails. So when you extract the data, you actually see the folder, and actually now I'm running you through the particular notebook so that we can get better understanding. So you load all the Sentinel data files, the Sentinel data, as well as export your training data, and you can see the results stored on your results folder. Then the second one is to show you how to actually inspect your training data. And this particular case, you'll see this particular workaround. So actually understanding how your data is arranged and using a random classifier, and also running principal component analysis step by step. And also we have other notebooks which can do the same as well similarly. Then finally you'll get a 3-dimension plot of your work. Then now remember the second step will be to look at the third notebook. So in the third notebook now is to evaluate the actual classifier, and actually here is to give you the example step by step. We have other classifiers, but now specifically for this one, you load all the parameters, and remember your training data has been now put in the results, which will be now be input for this particular notebook. Then you calculate the cross-validation of the results, and step by step, you'll actually see. So all these notebooks actually pre-run for you. Yours is to change and put in your data, looking at the performance of your classifier, and you can see good results over 90%. And then remembering it's a step-by-step from step 1 to step 5, and saving the results of that particular model in your results model, which is the folder, which is right here. Then in our next step, we'll actually now evaluate the classifier. And here now, step by step, is to take you through. So this uses the Sentinel-2 GeoMat as a baseline, as you can see for the whole continent, and now loading the model, and those are the coordinates of Faiyum in Egypt. And you can see the step by step from step 1 to step 4, and now loading step by step. You'll see your data sets using a GeoMat of that particular year, and loading all the bands, plotting all the results, and now having a look at your classified image, true color, probabilities of cropping. You can see the probability of cropping around Faiyum area, the classified area. Write your results in terms of a GOT file, which I put in that particular folder. And finally, we go to the last step, which is object-based classification. So in the final step now, step 5, is step by step, where we use the GeoMap classification and small image segmentation. Then we're predicting the model, and you have the results on an NDVI file in the results folder, and you can actually export, and you can see NDVI segments, and you can calculate pixel by pixel. And this is just quite key of some of the opportunities and results you can actually see on the object-based classifier. Then also you'll see the folder with the results, the prediction model, the probabilities, the test data, all of them step by step. And all this is possible through the great collaboration and partnership Digital Health Africa has with partners just like you. You could actually bring your data that you can use for this training, or you can even export some of the results. You can actually download and use it in your other GIS or QGIS software for any other further statistics and probability. So this is the objective of Digital Africa, is to empower you to actually be the one to tell the story. So also we have the same in our user guide, as you can see, giving you step by step the processes itself, how we've gone about these notebooks, working with different partners and champions in the continent, making sure you can use the platform the way you could have actually used Collect Earth to collect some of your data, and now actually using those points to train the model. And in the next step, you'll see how to inspect your training data, similar to what we did. And you see the step-by-step process, making sure that you're empowered principal component analysis, all of these possible. Then you can look at the next step, where you evaluate the classifier, random-based or support vector machine, SVM. I think things are really changing now, neural networks, etc. And you can get your model in your results folder. Then you can actually now do classification based on the data sets. So all this is based on the data that you've collected. And this was just an example for Faiyum in Egypt. So this one with 16 GB, 32 GB default, we were able to run it very well, fairly a short amount of time. And this is thanks to the great collaboration with the Open Data Cube technology and the community, which is gradually sharing all the work they do to make sure that we're empowered and making sure that we could also have the same presentation next week with my colleague Joseph in French to make sure that you're all empowered, able to use the user guide, looking at other notebooks that are available. So this was just scalable machine learning example. So we have very many examples. And we have a repository of other notebooks that you can use to monitor agriculture. We have the crop health notebook in your real world example. We also have the crop plan extend for Africa, which you can segment for different areas. We also have monthly vegetation condition anomalies, which you can segment for different countries. And the vegetation phenology are possible in optical as well as radar data, which is very key. Also, we have notebooks for vegetation monitoring, looking at vegetation change detection and phenology, which I mentioned we could generate using the Sentinel-2 and Sentinel-1 notebooks. These are just other possibilities. Then we also have burnt area mapping based on the specific incidences that we've had. And I believe last month we had a certain presentation, then the fractional cover very key to unlock land degradation in the continent. And also we have the free online courses that are very key to empower us use this platform. We have these courses in English and French, and we have these live sessions every week to make sure that we are connected, and also acknowledgements of the partners who've made this Digital Africa program a success, and we grow the partnerships. So today's session was just scalable supervised machine learning propositions in English. Next week it will be in French. Then thereafter we'll have a session on active irrigation cropping, which is very key, especially for the areas that we have been informed about the phenology, the cropping, and all these partners. Thanking them for connecting us with everybody. And these sessions are live every week in English and French, and wishing to pause for any question from the participants. Thank you so much for joining us.